Hi everyone, my name is Stefan Prostrelski. I'm a 10th grade student from Torrey Pines High School in San Diego. It is a great honor for me to be standing here to present my space settlement design project, which won first place in the 2018 NASA Ames Space Settlement Contest. My space settlement project is named Project EMLEE. It was inspired by a revolutionary technology from NASA that uses electromagnetic force to launch spacecraft. My design consists of a moon orbiting settlement which oversees mining operations on the moon, and the EMLEE system, which is an emergency evacuation system powered by electromagnetic energy. So why the moon? Well, the moon is rich in many important elements that are rare on Earth, including helium-3, which is an isotope that can be used in nuclear fusion. Also, the moon is relatively close to Earth, which makes it an ideal place to build a permanent settlement. Finally, the area of space near the moon offers a deep space environment for training astronauts on long space missions. So then why have a settlement orbiting the moon rather than simply on the moon? First reason is gravity. Spacecraft require less power to escape orbit in a microgravity environment as compared to a moon-based settlement. It also allows for the generation of artificial gravity on board to allow the crew to stay on the station for extended periods of time. The second reason is safety. News or foreign objects can cause significant damage to a moon-based settlement. While this is also true of a settlement orbiting the moon, a settlement that orbits the moon can simply change its course or orbit to avoid the foreign object. Finally, the last reason is economic. A settlement can be placed in geostationary orbit above the moon, and can also have its position changed easily. This is the overall design of my space settlement. The MODS 2033 is the moon orbiting space settlement, which oversees helium-3 mining operations on the moon, and can house 50 permanent residents. The EMLEE system is the emergency evacuation system powered by electromagnetic energy. They are attached to the undersides of each of the ring segments and can operate independently of each other. This is a more detailed design of the settlement. This is the ring, which contains all of the main facilities, the central axis on which everything is mounted on, the loading dock for incoming and outgoing spacecraft, an antenna for receiving energy transmissions from the moon, and should that system go offline, there are solar panels for backup. This is the design of each of the ring segments, using the crew quarters as an example, which contains the common rooms, crew residences, and the electrical and mechanical systems. 4 EMLEE systems are mounted to the outer intersection of the ring for easy access by the crew, and each segment is connected to the other via airlocks. Some of the special features of the MODS 2033 are its central axis, which also acts as an antenna for receiving power transmissions from the moon power plants. Next, the ring of the settlement spins at a constant rate, which generates artificial gravity, permitting the crew to stay on the settlement for extended periods of time. Because of the spinning ring, a counterweight is mounted on the central axis, which spins in the opposite direction of the ring spinning to cancel out the angular momentum. The station receives its power from nuclear fusion plants on the moon and stays above a constant location in order to receive power. Finally, the evacuation system consists of the EMLEE systems mounted on the ring segments, with 4 on each of the 6 segments. So there are a total of 6 ring segments: 2 farms, 2 crew quarters, a control room, and the labs. The 2 farms combined provide a total of 240,000 square meters of hydroponic gardens and a chicken coop to provide fresh food for the crew. The crew quarters contain the cafeteria, common rooms, gyms, medical facilities, and sleeping quarters. The control rooms provide command and communication facilities and oversee the mining operations on the moon. The labs have facilities for engineering, robotics, biomedicine, food science, and water and air quality testing. So now, the EMLEE system. The EMLEE is an electromagnetic launch system which uses electromagnetic energy to launch a projectile at extremely high speeds. The projectile in this case is the escape pod. This electromagnetic launch system uses twin conductive rails with a conductive projectile in between them, as well as the power source. An electric current is driven through the rails and the projectile back to the power source to complete the circuit. The electromagnetic fields produce a Lorentz force, which accelerates the projectile down the rails. My design was inspired by designs from NASA and the United States Navy. NASA has conceptualized using electromagnetic force to accelerate vehicles up to 600 miles an hour in 9.5 seconds. These vehicles could fly up to Mach 10 and then use wings to lift themselves into the upper atmosphere and launch a payload into orbit. The major challenge is that the track to launch this spacecraft would have to be very long, in many cases over a mile long, which makes them less practical for commercial use. The US Navy, meanwhile, has developed electromagnetic catapults to launch aircraft from aircraft carriers. These provide a more gradual acceleration and thus put less strain on the aircraft structure when compared to their steam-powered counterparts. And in July of 2017, the US Navy announced that they successfully launched and recovered an aircraft using their new Gerald R. Ford-class aircraft carriers. So why use the EMLEE system instead of other systems such as rockets? The first reason is that the residents of the settlement need to be able to access the evacuation vehicles as quickly as possible, such as in situations where the settlement faces imminent destruction. Some of the residents might not be able to reach their evacuation vehicles in time if they're located in a central hangar. The second is a speedy evacuation. The design of the EMLEE system was partly inspired by that of cruise ships. The EMLEEs are mounted to the 6 ring segments for speedy access by the crew. And instead of waiting for individual rocket engines to bring the evacuation vehicle up to speed, the EMLEE acts as a sort of catapult to launch the escape pod, and then its rocket motor brings it up to speed. Some of the design considerations of the EMLEE were to be able to reach a safe range of 100 kilometers within 10 minutes of evacuation, and be able to evacuate the entire settlement within 5 minutes. Also, the EMLEE systems cannot exceed the dimensions of the outer ring segment, which is 80 meters in width. EMLEEs also cannot have to be launched at an acceleration rate that the crew can tolerate. When fired, the EMLEEs produce a considerable recoil force which can shift the orbit of the settlement. To counter this, EMLEEs are mounted in pairs, with each one in the pair facing opposite directions, and then fired simultaneously. When the two are fired, the opposing recoil forces cancel each other out. Finally, the power supply needs to be able to rapidly discharge a large current. To solve this, capacitors will be mounted along the circuit leading up to the EMLEE system, and because capacitors have a much higher discharge rate than batteries. One of the key design considerations of the EMLEE was to be able to reach 100 kilometers within 10 minutes of launch, which breaks down to about 166 meters per second. However, one of the limiting factors is the amount of acceleration that the crew could tolerate. It's generally accepted that 10 Gs, or about 98 meters per second, is the maximum that humans can tolerate for a short period of time. At a 10 G acceleration, the escape pod will reach the target velocity in about 1.7 seconds. However, this will require a 141 meter rail. So thus, using an 80 meter rail, which fits within the dimensions of the ring segments, the escape capsule will be accelerated for 1.27 seconds and reach a velocity of 124 meters per second when it exits the rails. After launch, the rocket motor on board the escape vessel will then bring it up to the target velocity. So to summarize, the EMLEE system has a redundant design with excess capacity. The system also permits for rapid evacuation of the settlement. And to address concerns about recoil cancellation, the EMLEEs are mounted in pairs, with each of the two facing opposite directions, and then when they're fired simultaneously, the opposing recoil forces cancel each other out. And then to address concerns about angular momentum, The EMLEEs are fired perpendicular to the direction of the ring spinning so as to not interfere with its spinning. Finally, each EMLEE system has a protective cover which protects the system from foreign objects when not in use. When the system is ready to be fired, the cover is simply retracted. And last but not least, I would like to give a special thanks to my advisor, Mr. Bryn Bellier from Torrey Pines High School, and the support of my friends and family. Thank you for coming to my presentation, and I hope to see you at the poster session.